Hello, my name is Jatan Bansal. I'm a mathematics tutor and we will be discussing about the trigonometry over here. So we will be discussing about the basic trigonometric functions today and we will be covering the trigonometric identities as well. So we will be starting with a right angle triangle ABC and we will be talking about the three basic functions of sine theta, cos theta and tangent theta in terms of with the reference angle theta. So I'll be showing you the same in the diagram. So let's just take the triangle ABC as a right angle triangle with a B as the right angle ABC as a right angle. The angle C is the theta with which respect to which we will be talking about the basic functions. So the very first function I would like to start discussing is the sine theta. Sine theta is uh, my the side of the triangle opposite to the angle for which we are calculating the sine function. So the sine theta, the opposite side is AB divided by the hypotenuse. So that's my AC. So you can see that the side opposite to the angle theta as AB and the hypotenuse as AC. So I'll write sine theta is equal to AB upon AC. Okay, the next function is the cos theta, the base, the side adjacent to the one of the sides of the right angle and the one which is adjacent to the theta. So the cos theta would be computed as uh, this is the side which is under the right angle and again adjacent to the angle theta. So cos theta is base divided by the hypotenuse. So I'll write it as BC by AC. Now the next function is we need to look at is tangent theta. Tangent theta is the side opposite to the angle divided by the side adjacent to the angle which is there in the right angle as well. So we would say that tangent theta is AB upon BC. So trigonometry is very good and a very interesting course. You will find and things are very much related. And what about trigonometry? Interesting about the trigonometry is whatever you'll keep on learning, you'll keep on watching it implemented in every new concept you'll learn about trigonometry. And as you progress in your school, in your standards, so you'll find that the trigonometry is being used in your calculus, somewhere in your geometry, coordinate geometry. So let's just move a little bit ahead in the trigonometry itself. So there are three basic identities in the trigonometry. So they are uh, okay. So let me write the basic and the fundamental identities, which are the three identities, and then we will see how to prove them. So there are first identity is sine square theta plus cos square theta is equal to 1. I must be saying that it might be appearing a little bit opposite to you because the camera isn't just front of me, and whatever I am just writing is actually going as a reflection to you. So just to make you understand, so sine square theta plus cos square theta is equal to 1. So let's see how we just get this result. So everybody knows about the Pythagoras theorem that the perpendicular square plus the base square is equal to the hypotenuse square. So what is our perpendicular is AB. So I'm writing AB square plus my base square, that is the BC square, that's BC square is equal to my hypotenuse square. So we know from the from the um, from the ninth standard mathematics and the geometry section, we have learned about the Pythagoras theorem. So this is actually nothing else but the Pythagoras theorem, right? So everybody knows about it. So what, in order to achieve the first identity, which is the very basic identity, so you can see this sine square theta plus cos square theta is equal to 1. So what I'll do in this equation, I'll divide both sides by AC square. So let's divide by AC square. So if I divide by AC square, So it will look something like this to you. I hope this makes sense. If I'm just gonna split it in three more strips. So what I can do is, this is just going to be cancel with this one, right? So this turns out to be the 1. Okay, so I'm cancelling it, and this will be 1, and I'm splitting that side, taking AC square independently below each of AB square and BC square. Let me show you what I'm saying, what I mean to say by that. By taking independently and individually below as a denominator in for AB and BC square, AB square and the BC square. So you can see this turns out as 1 because we divided both sides by AC square, and this AC square was already here in the numerator, so it just cancels out, right? So okay, now I can write AB square upon AC square as AB by AC whole square plus BC by AC whole square is equal to 1. I hope it makes sense. If you look at this, I just didn't do anything much in this. AB by AC, I just put it as whole square. As we know from the very basics of algebra, if I just write x square by y square, which is equal to x upon y square, x divided by y square, right? So I hope this makes sense. Now from here, AB by AC, what I see is AB by AC. AB is my perpendicular and AC is my hypotenuse. So we just check that it is sine theta. So it becomes sine squared theta, and this is BC by AC. BC by AC. So the base divided by hypotenuse is cos theta, right? So I would write again here, AB by AC is equal to sine of theta. BC by AC is equal to cos theta. So for the sake of avoiding confusion, I rewrote it. AB by AC is equal to sine theta. We just saw from here AB by AC is equal to sine theta, right? So I'll be just replacing the AB by AC and BC by AC with sine theta and cos theta. So what I will be getting is sine square theta plus cos square theta is equal to 1. So I'm just putting it in a box so as to highlight what we have achieved. So for the sake of understanding, we can see that I substitute AB by AC with sine theta, so it becomes sine square theta, and for BC by AC I substitute as cos theta, so it becomes cos square theta. So that's it. We got the first time. Thank you. Thanks.